Alright, this is your assignment from Monday, December 2nd. This is page 281, and you had to do 13 through 27. 13 through 27. Just the odd problems. We were going to do them all, but we ran out of time a little bit. This is solving quadratics by completing the square. So we'll run through a few of these things. Here's problem number 13 to get you started. 13, we've got x squared minus 3x equals 28. Now, it's called the method of completing the square because what we want to do is take this partial trinomial. I call it a partial because it's missing the constant term, and we want to add the proper thing to make it a perfect square. Okay. Remember, we had a series of steps. Number one was constant to the right-hand side. That one's already done. Coefficient of x squared, we just want to be a 1, and that's already done. To determine the number that we want to add to this binomial right here, to make it a perfect square trinomial, we take the b value, we divide it by 2, and we square it. So in this case, our b is -3, and we divide that by 2, and we square it. Now you don't really have to worry about the sign, because you are going to square it, so it's always going to be a positive number that you add. So we square -3, we square 2. And so we add that to both sides, and so our equation now becomes x squared minus 3x. I'm going to add that 9/4 to the left side, and then good math tells us if you add something to the left-hand side, you better add it to the right-hand side so that your equation stays balanced and true. Okay. At this point, this now is a complete trinomial, and that's going to be a perfect square every single time as long as you add the correct number. So if I were to factor this fraction over here looks tough to factor, but really all you do is take the square root of it, and that's what goes in each spot. The plus sign here tells us the 3/2 will have the same sign in each binomial. The negative tells us they'll both be negative. Now on the right-hand side, we're going to have to do math, fraction math, and add those two together. You can use your calculator at that point to get a common denominator or to add them together. The common denominator here looks like it would be 4, so I'm going to take 28 times 4. And that gives me 112 over 4, I hope that's right, plus 9/4. So now those can be combined. On the left-hand side now, I've got x minus 3/2 quantity squared equals 121/4. Okay, and this is what we call completing the square. We've completed this up here, made it a perfect square, and you can see it now written as that perfect square. Okay, and at that point I can solve the system, or solve rather the equation, by taking the square root of both sides. So I'm going to take this perfect square trinomial, move it, and try and figure out where it went to here. Well, I'll just rewrite it up here. But x minus 3 over 2 squared equals 121/4. We will square root both sides. On the left-hand side, that eliminates that squared up there. On the right-hand side, when we square root, we get plus or minus 11/2. And so solving for x, we just add 3/2 to both sides. And that I'll put in front of that plus or minus 11/2. And so we do get two answers here. We ended up with x is 3/2 plus 11/2, which is 14/2 or 7. Or x is 3/2 minus 11/2 equals -8/2 or -4. So those are the two solutions to this equation. Now, at that point, we are done. I'm going to really quickly show you that this equation then could have been done or solved much quicker. Okay. Now we wanted to practice completing the square, and that's why we wouldn't have done it this way, the way I'm about to show you. But normally what I do when I'm asked to solve a quadratic is I get it equal to 0. I try to see if it factors. X and X, 4 and 7. I want the 7 negative because I'm looking for a negative 3 and the 4 positive. The zero product property tells me each factor has to equal 0 for that equation to be true, and so I get two answers, negative 4 and 7. The same two answers I got over here by completing the square. Okay, let's go to the next problem. Let's take a look at problem 15. 15 says the following. Solve the equation x squared plus 6x plus 41 equals 0. Okay. Step 1, constant to the other side. This is negative 41. Check to make sure the coefficient of x squared is 1. Determine the value you're going to add to both sides with b over 2 squared. That's 3 squared. Showing you all the steps is 9. So we're going to add 9 to both sides. So I rewrite my equation and I add 9 to the left and I add 9 to the right. On the left hand side, that is now my perfect square. You can factor it all out so you can see that it is a perfect square if you want, like I've shown. On the right hand side, we just let the math do its thing. We now are at the point where we have a nice equation that we can solve by square rooting both sides. Okay, I'll rewrite that right up here. X plus 3 squared equals negative 32. We solve this by square rooting both sides. Let's use that color. And I get x plus 3 equals plus or minus root negative 32. And you can see now why we practiced just the other day taking square roots of negative numbers. I'm going to take that 3 over by subtracting it. And now I'm going to simplify this root negative 32. First I take out the imaginary number I. Okay, 32 factors is 16 times 2. And I can take the square root of 16. So my final answer is negative 3 plus or minus square root of 16 is 4. I've got my I outside, and the 2 is left on the inside. And that is my pair of solutions. They're a complex pair, negative 3 plus 4i root 2, and negative 3 minus 4i root 2. The very last one I'll do is problem 27, and I'm just going to do that one because generally they put the tougher ones near the end of the problem set. But all of them have the same basic method. Okay, so we're solving this by completing the square. Step 1, take the constant to the other side. Step 2, divide everybody by 4, the coefficient of x squared. We want that coefficient to be just 1. Okay, so there's our first two steps. Next we're going to take the b value, divide it by 2, and square it. b in this case is 1. It's right in front of the x. Doesn't show the 1, but it's implied. And I square 1 and get 1, and square 2 and get 4. So I'm adding 1/4 to both sides. So here I go. I add the 1/4. Add it to the left. I got to add it to the right. That on the left hand side may not look very pretty, but it is a perfect square. Square root of 1/4 is a half. And a half x and a half x add up to 1x, which is what's in the middle here. And 3/4 and 1/4 is just 1. And so I get this perfect square equals 1. And so now I can solve that. again sliding over here, rewriting the equation so we can see all the steps. I square root the left and square root the right. That makes that square disappear, and the square root of 1 is plus or minus 1 when I'm solving an equation. And so it's negative a half, subtract a half from both sides, plus or minus 1. Negative a half plus 1 is a half, and negative a half minus 1 is negative 3 over 2. There's my two solutions, and I hope that helps.